Good day, everyone. So we have discussed last week about the cooling water system. So for today, I have to show you the equipment used for our water analysis for jacket cooling water and for the boiler water. First, I will show you the equipment of our boiler water for testing. First is equipment used taking a DEHA. So we will discuss this DEHA when we are in our topic about the boiler water. So for this time, I will show you this equipment. Another is the spectrometer. The chemical used for determining the alkalinity of the boiler water. For taking the chloride content of the boiler water and your cascade water. And the solution for the DEHA. And the reagent used for taking the pH content of the boiler water. We have also the pH indicator to determine the pH level of your water, if it is acidic or alkaline. This is for the lower test. This one is for the higher test for the boiler water. So another set of our testing kits is for our jacket cooling system, which is the jacket cooling water. For this time, I will show you the chemical used to determine the nitrite content of your jacket water. So for this time, why we have to get the water analysis to determine the nitrite content of your jacket cooling? So what is the importance of this test in your jacket cooling system? Why we have to test the nitrite content of the jacket cooling? First is to determine if the cooling water system of your main engine doesn't have any much corrosion, and to determine that the water or the cooling effect of your cooling system is good. Now, this nitrite will determine the effectiveness of your jacket cooling. This is to test whether your water can cause corrosions and scale formation. First, we're going to take the nitrite test for your jacket cooling system. This which is not only for your main engine but also for your auxiliary engines. So we have the water sample for your jacket cooling system. So now we are going to test for the alkalinity for the nitrite content of our cooling water. First, we have our syringe. This is only 5 ml. So we're going to have 5 ml sample. Put in the testing bottle. Now we will add a distilled water to make this 50 ml sample. For this time, we will going to add the nitrite 1 tablets. We're going to add 2 tablets to make our water clear as white. Now, we're going to add the tablet to know whether there is a presence of the color will turn to pink if it reaches the required value. We have 5 already tablets. Still 6 tablets. So now we can compute how much is the nitrite content of our cooling water. To compute with this, we're going to multiply the number of tablets into 180. So the minimum of this nitrite test is 1,000 to 2,500 is the normal rating value. Now we have 6 tablets. So we wait for 1 minute to settle down the chemical. So the color was faded. So we're going to add another tablet to make the color permanent. So now it's already 7 tablets. Okay. So we're going to compute the amount of the nitrite on our cooling water system. So the computation is number of tablets multiplied by 180. So it will come up with 1,260. So the normal range of your cooling water system, the nitrite, is 1,000 to 2,500 or more. So better, you will going to have in range between 1,000 to 2,500. So another test we're going to take is the chloride test for our system. So we will going to have a 50 ml sample. We will put in our test bottle. So we will see the color of our water cooling system if there is a content of chloride. So what is the chloride test for? So this will determine if our system was contaminated by the salt water. The type of cooling system we have here is the open system, which is we use seawater as a cooling medium. Not like the closed circuit, which is the seawater is the only medium for central cooling, in which the jacket cooling system was cooled by the low temperature fresh water. So now we will going to take the chloride test for our system. So we have the chloride tablets. So we use the 50 ml sample. We will add 1 tablet to know if there is a salt content in our system. Now it turns into yellow. So means we will going to find the color turn into red brown. So when the color turns into red brown, means to say that's the time that we're going to compute how much chloride content of our water. Now we're going to add another tablet. Still yellow, another. So now it turns into red brown. The computation of this is number of tablets of chloride tablets times 20 minus 20, which will going to give you a value of 40 ppm. Now, so the normal value of our chloride content is only 50 ppm. Above 50 ppm, which it shows that there is a seawater contamination in our system. Okay. Another test we're going to take is for the pH value of our cooling water system. So another, we will going to put another 50 ml of our sample. We're going to put our pH indicator strips to know if our cooling water system is acidic, it is in normal, or it is alkaline. We will going to put our paper strip for about 1 minute. So after 1 minute, we will going to see how much will be the value by comparing it in this table. Okay. After 1 minute, we'll compare into this table if how much the pH value of our cooling water. So what will be the value? So it seems the value of our cooling water system is 8.5. Now, going back to our nitrite test. So when our nitrite test comes lower, less than 1000, we're going to add a Roper NB chemicals to rise our nitrite content value. So if the value is 1000 below, we will going to add the chemicals for the cooling water system, which is the Roper NB liquid. Next time, we will going to show how to take the boiler water analysis